Hello everyone. So in this video, I'm going to discuss JEE Mains 2024 Shift 2 of 30th January. So I have received around 16 to 17 questions from my students. So let's start. So the first question is very basic question. So they basically asking about the different, you can say Maxwell's equation. So A, so we have to match the columns. So A, which is in close integral of B dot dA equals to 0. So this is nothing but the Gauss law for magnetism. So A goes for Q, right? So A corresponds to Q, and B is nothing but the Gauss law, right? Integral E dot dA is equals to Q enclosed by epsilon naught. So this is S. So B corresponds to S, and integral B dot dl is mu times I enclosed. So this is nothing but the Ampere's law, which is R, and integral E dot dl is minus d phi B by dt, and this is nothing but Faraday's law. So D corresponds to P. So directly you can say the definition based question. Now the next question is, a planet exists of mass 1/6 of the mass of the earth. So there is a planet, and mass of the planet is 1/6 of the mass of the earth, and the radius of the planet is 1/3 the radius of the earth. If the escape speed from earth is 11.2 kilometers per second, then find the escape speed from that planet. So we know that escape speed is root of 2 gm by r, right? So for the planet, so I'll write mass as mp and r as rp. So this will be root of 2 g me by re, and there will be 6 in the denominator and 3 in the numerator. So this becomes 2 here. So I can write this as 1 by root 2 times the escape velocity for earth, right? So this will be 1 by root 2 times 11.2 kilometers per second. So 11.2 divided by 1.414. So when simplify this, it comes out to be nearly 8 kilometer per second. So again, very basic question. Okay, next question. A block of mass 1 kg is ascended on an inclined plane by a distance of 10 meter. So we are displacing this block by a distance of 10 meter up the incline by exerting an external force of 10 Newton, right? Find the work done against the friction, right? So we know that since the block is moving, the friction will be kinetic. So there will be a kinetic friction. So normal reaction will be given by mg cos theta. So we can say Fk will be, m is 1, g is, I'm taking it as 10, cos 60 will be 1 by 2 times the coefficient of kinetic friction, that will be 0.1. So this comes out to be 0.5, right? So 0.5 Newton is the force, frictional force. So work done by the frictional force will be 0.5 times the displacement, and it should be negative, right? So minus 5 joules. And but we have to find the work done against the friction, that will be negative of this value. So the answer will be 5 joules. Right, now let us see the next question. The slope of the graph between the stopping potential and the frequency of the incident photon in photoelectric effect is, okay. So we know that by Einstein's photoelectric equation, h nu, which is the energy of the photon, will be work function plus E times V naught, where V naught is the stopping potential, and we need to find the slope of V naught versus frequency graph. So we can say V naught is h by E, nu minus phi by E. So the slope will be h by E. So that is the answer of this question. Next, again, this question is from Newton's law. So we have given 3 blocks, 2 kg, 3 kg, and 5 kg, and they are connected with 2 strings. And let us say the tension in the string connecting the block 2 kg and 3 kg is T1, and the tension in the other string is T2. Right, so we are exerting a force 10 Newton, and there is no friction anywhere, right? So all the 3 blocks will move as a single unit. So if I consider them as a single unit, then the acceleration produced will be the net force, external force, that will be the 10 Newton in the forward direction, divided by the total mass of the system, that will be 2 plus 3 plus 5. So it comes out to be 1 meter per second square. Now if I draw free body diagram of 2 kg, there is a tension T1 acting in the right direction. Now this tension will provide acceleration to 2 kg block. So T1 is equals to 2 times the acceleration 1. So this will be 2 Newton. Now if I draw free body diagram of 5 kg, so there is a 10 Newton force acting in the right direction and there is a tension T2 acting in the left direction. And it is having an acceleration in the right direction. So the net force in the direction of acceleration will be 10 minus T2 is equals to mass times the acceleration. So T2 comes out to be 5 Newton. So these are the answer, right? For these values. In the next question, we have 2 moles of monatomic gas is mixed with 3 moles of diatomic gas. Find the gamma of the mixture, right? So the value of gamma, it will be N1CP1 plus N2CP2 divided by N1CB1 plus N2CB2. Okay, so here CP1 for monatomic gas, CB1 will be 3 by 2R and CP1 will be 5 by 2R. And for diatomic gas, CV2 will be 5 by 2R. So I'm considering rigid diatomic molecule and CP2 will be 7 by 2R. And N1 is 2. So this is N1 and this is N2. So we can say 2 times CP1 that is 5 by 2R plus 3 times CP2 that is 7 by 2R divided by 2 times 3 by 2R plus 3 times CV2 that will be 5 by 2 R. Now this R will get eliminated. So we have, and even this 2 will get eliminated. So we have 10 plus 21 divided by 6 plus 15. So this comes out to be 31 by 21. So that should be the answer of this question. Again, formula based question. Now let us see the next question. A square loop of side 1 meter is carrying a current of 5 ampere as shown. If the magnetic field at the center is x root 2 times 10 raised to the minus 7, find the value of x. Okay, right. So if we have a finite wire and we want to find the magnetic field at a point which lie on the perpendicular bisector, right, on the perpendicular bisector, and if this angle is theta and this distance is d, so the magnetic field at this point will be mu naught I upon 4 pi d, where d is the distance of that point from the wire times 2 times the cos theta, right? So in this particular case, we have 4 such sections and this angle is 45 degree, right? So this angle is 45 degrees. So due to one particular section, the field will be mu naught I upon 4 pi d, in this case will be 1 by 2. This distance is 1 by 2 times 2 times cos 45. So cos 45 is 1 by root 2. So that is due to one section. Now we have 4 sections, all will be having field in the same direction, that will be out of the plane. So here the field will be out of the plane due to this current. So if I multiply this by 4, I will get the answer. So mu naught upon 4 pi is 10 raised to the power minus 7. Current is given as 5 ampere. So we have 2 here. So it becomes 4 divided by root 2 times 4. Let me again check. So we have 2. Yeah, 2. So 2 in the numerator. Okay, right. Now let us simplify this. So it will be 16 times. Okay, right. We have to take root 2 in the numerator. So this will be 80 by root 2. So we'll rationalize this. So this will become 40 root 2 times 10 raised to the power minus 7. So if we compare our answer with the given thing, so given answer, x value comes out to be 40. So x is 40. So 40 is the answer, right? So again, it is a standard question that we always cover in when we are teaching this concept in class. An electron in fifth excited state of helium positive atom moves to first excited state. Find the number of possible spectral lines. So fifth excited state corresponds to n equals to 6 and first excited state corresponds to n equals to 2. So this is 6, then we have 5, 4, 3 and 2. Now if the electron is getting de-excited from the 6th energy level, so there are how many possibilities? 1, 2, 3, 4, right? So we can have 4 spectral lines like this. If the electron is in the 5th, so then we'll be having 3, and then if the electron is in the 4th, then we'll be having 2, and like this, when in the electron is in the 3rd, then we'll be having only one spectral line. So it will be 4 plus 3 plus 2 plus 1, so it comes out to be 10, right? So 10 is the answer. Or there is one more way you can use n into n minus 1 by 2, where what is n? So if this is 1, 2, 3, 4, 5, so this is n, right? 5. So 5 times 4 by 2, so the answer will be 10, right? So do remember this. In the circuit, reading of voltmeter is 1 volt, then the resistance of the voltmeter is, now this is the voltmeter, and we have given the voltage as 1 volt. So since voltmeter and 100 ohms are connected in parallel, so both will be having the same potential difference. So can we find the current in 100 ohms resistor? Yes, we can find that. So this current will be V, that is 1 by 100, so it will be 10 milliampere, right? And if 1 volt is across this 100 ohms, then the remaining 4 volts, because it is 5 volt battery, right? So the remaining 4 volt will be appeared across 200 ohms resistor. So from here we can find the current through 200 ohms resistor. So that will be 4 divided by 200, and I can write this as 2 by 100. So it will be 20 milliampere. So if this is 20 milliampere, this is 10. So the current through the voltmeter will be 10 milliampere by Kirchhoff's junction law. Now, if the current is 10 milliampere, voltage we know from these two values, we can find the resistance. Resistance will be V by I, and I is 10 milliampere. So it will be 10,000 in the numerator. So this will be 100 ohms. So 100 ohms is the resistance of the voltmeter, right? Next. So if minus Q charge rotating around an infinite long wire having a charge density lambda, so that is linear charge density at a distance r, then calculate the time period. So we have given an infinite line charge, and the charge density is given as lambda, and there is a negatively charged particle which is orbiting in a circle, and the center of the circle lie on this line. So if this is the negatively charged particle, due to this positive line charge, there will be a field which is away. So the field is in the right direction, and due to this field, there will be a Coulomb attraction on the negatively charged particle. So the force experienced by this charge will be towards the center of the circle. Now this force will provide centripetal acceleration to this charged particle to move in a circular path. So this Fe is equals to the centripetal force. So I can say the electric field by a line charge is lambda upon 2 pi epsilon naught r, where r is the radius of this circle. So lambda upon 2 pi epsilon naught r times the charge, that will be the force experienced by the charge, and this will be equals to mv square by r. So this r will get cancelled out. So from here we can find the speed of the electron, speed of the negatively charged particle. So that will be lambda q upon 2 pi epsilon naught times m, square root of that. So this is speed. To find the time period, so time is distance upon speed. So 2 pi r divided by the speed, which is 1 by v. So here we can write 2 pi epsilon naught m divided by lambda q. So if I take this 2 pi r inside, so we will get 4. So we have 4 pi square times 2 pi epsilon naught m r square divided by lambda q. So it will be 8 pi cube epsilon naught m r square divided by lambda q. So that should be the answer of this question. Right, so now let us see the next question. So if 1000 drops of surface energy E1 are merged to form one bigger drop of surface energy E2, then we need to find the ratio of the energy. Okay, so what is the surface energy? So if we are combining 1000 drops into one bigger drop, so here first we'll conserve the volume. So volume of 1000 small drops should be equals to the volume of big drop, right? One big drop. So if I take the radius of the big drop as capital R and the radius of small drop as small r, so I can say it will be 1000 times 4 by 3 pi r cube should be equals to 4 by 3 pi capital R cube. So 4 by 3 will get eliminated. So r comes out to be 10 times small r. So E1 is 1000 times 4 pi r square times the surface tension, and E2 will be 4 pi capital R square, that will be 10R square times T. So if I take the ratio, so E2 by E1, so that will be 4 pi T 100R square divided by 4000 pi R square times T. So pi R square times T will get cancelled out. So this comes out to be 1 by 10. So 1 by 10 is the answer. Okay, so he developed W if there is a wire whose resistance is R. So if there is a wire which is having resistance R, the heat produced is W. So I'm assuming that we have a constant EMF source which we have connected across the end. So this is V. So W will be V square by R, let us say for time T, right? Now if I cut this wire into two parts and join into parallel, so if I cut this wire into two parts and join them in parallel and again connect them with the same voltage source. So this is R by 2, this is R by 2. So the effective resistance will be R by 4. So here the heat produced for the same time will be V square upon R by 4 times T. So that will be 4 times W. So the answer should be 4W, right? Again, very basic question. So find voltage across 2.5 kilo ohms resistor. So we have given this circuit. There are two diodes. One is germanium, other is silicon. And nothing else is given in this question. And you should remember, so in order to make this germanium conducting, there has to be some minimum voltage, that is 0.3 volt we have to apply. So there will be a 0.3 volt of potential drop across the germanium in the forward biasing. Similarly, in the silicon, this value is 0.7 volt. Sometimes it is given in the question, sometimes it is not. So do remember these values. So now we need to find the voltage across the 2.5 kilo ohm resistor. So if out of 15, if overall 1 volt is getting dropped across these two diodes, then the remaining voltage will be across the resistor. So the answer should be 14 volt, right? Okay, now let us see the next question. So length of the pendulum is 4 meter and take G as pi square. Pendulum is taken to an altitude R, where R is the radius of the earth. Calculate the time period. Okay, so if I want to find the effective G at the distance R, at the altitude R, so what is that G? So G will be G. So here the altitude is not comparable with the is comparable with the radius. So we have to use the general formula. So it will be 1 plus H, which is R by R square, right? So this will be G upon 4. So acceleration due to gravity at this particular point A will be G by 4. So the time period is given by 2 pi root L by G effective. So here the G effective is G by 4. So it will be 2 pi root L is given as 4 meter. G effective is pi square by 4. So it comes out to be 2 pi 4 by pi. So pi will get cancelled out. So it comes out to be 8 seconds. So that should be the answer of this question. Next, ice at temperature minus 10 degrees Celsius is converted to steam at 100 degrees Celsius. The curve plotted between the temperature and versus the time when it is being heated by the constant power source. Again, it is a standard question. It all like whenever we teach heat, this portion is covered where we'll plot this graph. So here we have temperature in degrees Celsius. Here we have time, and we are supplying heat with a constant power source. So what would happen? So this is 0 degree. So the graph should start. So there are 4 graphs were given, and we have to find the correct graph. So if the temperature is minus 10 first, the temperature will increase as we provide the energy. So it will be a linear relation, right? So when it attains 0 degree, then we have to overcome the latent heat of fusion, right? Right? We have ice here, and then we have to overcome the latent heat of fusion. So here we have ice plus water, and when we have right, so when we have water, then what would happens again? It will gain energy. It will gain energy, and the graph will be linear, and this will be 100 degrees Celsius. At 100 degrees Celsius, when we have at this particular point, we have to supply latent heat of vaporization, right? So here we have water, here we have water plus steam, and after that we have steam. So that should be the nature of the graph, and 4 graphs were given, so we have to pick the right one. Okay, right. So now let us see the next question. Two particles are projected from a tower 400 meter and angle 45 degree and 60 degree with the horizontal. If they have the same time of flight, find the ratio of their velocities. Okay, let me just show you. So this height is given as 400 meter, and two projectiles are launched at 45 degree and at 60 degree, right? Let us say this is u1 and this is u2. They have same time of flight. Okay, so if I apply equation of motion in a vertical direction, so I can say 400 will be equals to, say for the first projectile, it will be minus u1 sine 45 degree t plus half gt square, and for the second projectile it will be 400 equals to minus u2 sine 60 degree t plus half gt square. So if you compare these two equations, t is same for both the projectile. So if t is same, right? So for t to be same, this term, the coefficient of t has to be same, right? Only in that case we'll get the same time. So u1 sine 45 degree should be equals to u2 sine 60 degree. So u1 by u2 will be sine 60 by sine 45. Sine 60 is root 3 by 2. Sine 45 is 1 by root 2. So I can say it will be root 3 by 2 times root 2. So this is root 3 by root 2. So that should be the answer of this question. Okay, so next we have to, it is from a dimension analysis. So we have given c is the speed of light, g is the universal gravitational constant, and h is the Planck's constant. And this left hand side dimension is same as the dimension of mass. So let us apply dimensional analysis in this question. So we have given c, so the dimension of c is L t raised to power minus 1. And for g, it will be f r square by m square. So this will be m raised to power 1, L raised to power 1, t raised to power minus 2, L square upon m square. So this will be m raised to power minus 1, L cube, t raised to power minus 2. So m raised to power minus 1, L cube, t raised to power minus 2 raised to power minus 1 by 2. Then Planck's constant, we can find the dimension of Planck's constant by using the energy of photon, which is E by nu. Energy is m raised to power 1, L raised to power 2, t raised to power minus 2, and frequency is t raised to power minus 1. So it will be m raised to power 1, L raised to power 2, t raised to power minus 1. So this will be m raised to power 1, L raised to power 2, t raised to power minus 1 raised to power 1 by 2. And this is equals to m raised to power 1. Okay, let us and L raised to power L t raised to power minus 1 raised to power p. Okay, let us club the like terms. So m raised to power plus 1 by 2 plus 1 by 2 Then we have L raised to power P plus 1 minus 3 by 2, and then T raised to power minus P plus 1 minus 1 by 2. Okay, so this will be M raised to power 1, L raised to power 0, T raised to power 0. So that is correct, right? That is okay. Now the power of L, that is P minus 1 by 2, should be equals to 0. P 1, yes, minus, so P has to be 1 by 2. Let us check for that, for the exponent of time. So minus P plus 1 by 2 is equals to 0. So P comes out to be 1 by 2. Yes, so the answer of this question will be 1 by 2, right? So again, like if you look at the question from this ship, I don't think like one or like if I leave one or two questions, most of the questions were easy, right? So all the best for your exam. Thank you.